Hello, my name is Jan. I am a man, and I would like to talk to you about male sterility. Cytoplasmic male sterility in cabbage, that is. In plants, we all know there are female parts in the flower and there are male parts in the flower. And when plants make seed, the seed is the result of sexual reproduction, so it means exchange of genetic material. The mother contributes her half, the father contributes his half, and then the embryo is the result of that union. Plants have different strategies to reproduce in challenging environments. Sometimes you have some plant species that have plants that make only female flowers and other plants that make only male flowers, and the only way that they can reproduce is by exchanging genetic material with another plant. So that means outcrossing. Other plants have flowers that have both male and female parts, and they have a choice. Would they accept pollen from another plant, or should they accept pollen from their own flower? In other words, should they outcross or should they inbreed? When conditions are really stressful, often what you see, it's good to say we need more variation in our population, because through natural selection we select the strongest and we can adapt to changing environments. But if the plants are in a very, very happy environment, maybe what they want to do is they want to continue inbreeding because they already have the right genetic combination for that particular environment. Those are things that happen in nature, they happen naturally. There are naturally occurring mutations that cause male sterility. And we as breeders have looked at that and says, you know, we can use that, because as breeders, we want to produce hybrid seed. We don't want to produce inbred seed. If you're using open pollinated material, you'll get a combination of inbreds and outcrosses and stuff like that. But in hybrid seed production, you want 100% outcrossing when possible. In cabbage, that's difficult because we've always relied on a self-incompatibility system. So sometimes some lines will not easily accept their own pollen, but sometimes they will, and then we have problems with a lot of inbred seed, and then we have to throw the seed out, and that means that we have to come to you, the grower, say, sorry, no seed of winterboard this year, too many problems with inbreds, seed production problems. So how do we solve that? Well, there is a cytoplasmic male sterility gene. It occurs in the cytoplasm, so on the chloroplast of a radish. This has been incorporated in lots of cabbage breeding lines, and you can see what that does in the flower itself. Let's take a close-up look on these flowers. Here we have a male sterile line, and here is a male fertile line. You can see in this flower, this male fertile flower, in the center of the flower, the anthers. Those little yellow stubs, that's where those are male parts that produce the pollen. The bees take that pollen and transfer it to another plant. And in the middle of this plant, you can see the female part, the pistil. Well, there it is. Actually, you can see it better on this male sterile plant. See, the only part that we see here is the female part. See that stub that's in the middle? That's the pistil that accepts the pollen, and that pistil is attached to the ovary where the seed is produced. But you can also see in this male sterile flower no anthers. So again, let's get an example of a male flower here, a male fertile flower, this one over here, with anthers and without anthers. You see the difference? So if you, as a grower, want to know whether you have a male sterile variety or a male fertile variety, all you got to do is look at the flowers and look for the male parts. Are they there or are they not? Is the flower sterile or is it fertile?